Okay, so in the last video, I showed you how to combine like terms by adding them. So now I'm going to show you an example of what it looks like to subtract those like terms. All right, so what's important to note here is that this subtraction is we are subtracting this entire expression from this entire expression. So what we need to make sure that we do is this subtraction sign actually goes with the x squared, it goes with the 4x, and it goes with the 6. So if it helps you to remember that to rewrite it, you can do that. Okay, so you could actually rewrite this as 5x plus 9 plus 3x squared, and then I'm going to subtract the x squared, and then I'm going to subtract the 4x, and then I'm going to subtract the 6. Okay, and that just gets rid of the parentheses and reminds you that each of these is subtraction. Whichever one works for you is perfectly fine as long as you remember to carry that subtraction all the way through. I don't have a problem with you leaving it this way, but if this helps you, by all means do that as well. This is completely up to you. I'm just showing you options, okay? All right, so we're going to start the same way as we did before. So we have 5x. Remember that x is represented by these long skinny rectangles, so I'm going to draw 5 of them. 1, 2, 3, 4, and 5, okay? And then I have 9, okay? Remember that our single number, our constant, is represented by the squares, so I need to have 9 of those. 3, 4, 5, 6, 7, 8, and 9. And then finally we have 3 of these x squareds. So the 3 large squares are represented by the x squared. So remember, here's x, 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 and x. Each of those represents 1, and each of these represents x squared. Okay? So that's the first expression. Now, the second expression, all right, is represented with an x squared. So I'm going to draw 1 x squared. Remember that anytime there is not a coefficient here, anytime there is not a number in front of that variable, we assume that the number is 1. So there is 1 x squared. Okay? Then we have 4x, means 4 of these. Each of these represents 1x. So here's an x, here's an x, here's an x, and the last one is an x. And then we have 6 of the single units. So each of those represents 1. Okay? So we have now the need to subtract. Okay? We're going to subtract these and see what we come up with. So as we subtract these, all right, we have 3 of these. Okay, we have 3, 1, 2, 3 x squareds. Okay, 3 of them. I subtract 1 of them. Take it away. How many am I left with? 2. 1, 2. So I am left with 2 x squareds. Okay, 2 of those. All right, and so then we do the same thing with the rods. Okay, so I have 5. So 1, 2, 3, 4, and 5. And I am subtracting 4 of them. 1, 2, 3, 4. So I take away 1, 2, 3, 4. And I am left with 1. So that leaves me with 1x. Okay? And then the last one that I have are my singles. And I start with 9. So 1, 2, 3, 4, 5, 6, 7. Oops. Switch colors because I don't have enough. 8 and 9. Okay, the colors don't matter. That was just, I didn't have enough of the yellow ones. So I have 9 singles. And I need to subtract 1, 2, 3, 4, 5, 6 of them. So 1, 2, 3, 4, 5, 6 are all gone, and I am left with 3. So after I subtract these, all right, there are 3 of them, I am left with 1, 2, 2x squared, 1x, and 3 with no variable. Okay, so 2x squared plus x plus 3. So I have these 2x squareds, this x, and these 3 singles is what I'm left with. None of those are any more alike. Okay, so I cannot add anything else together. That is my final answer. Okay, so hopefully those visuals help a little bit. I'm going to show you a couple more examples, and I'm going to show you another way that you can do this if like color coding helps you. The next example might help you with kind of understanding this a little bit better. Hopefully the visual of the squares helps a little bit. And so we will do a few more examples in the next video.